Every day, millions of soybeans enter factories as small, hard seeds, dry and yellowish. Hours later, they leave transformed into a white, creamy, ready-to-drink beverage headed straight for store shelves. But how can a seed that looks so simple turn into something so similar to milk? And at exactly what point does a soybean stop looking like a bean and start becoming a beverage? Welcome to Factories and Facts. Today, you're going inside one of the food industry's most fascinating transformations, the complete journey from soybean to soy milk. And here's the most interesting part. The white liquid you see inside the carton does not exist inside the bean. It has to be extracted, separated, treated, and stabilized through a carefully controlled sequence of steps. Long before it ever reaches tanks, pipes, and stainless steel machinery, the soybean destined to become milk begins its journey in a completely different setting. The field. An open-air farm. It all begins when seeds are placed into the soil in rows by planters that move across vast fields, spacing each one according to a precise planting pattern. With favorable moisture and temperature, germination begins. The tiny plant breaks through the soil and starts a cycle that will turn that seed into a plant loaded with new pods. During the early stages, green dominates the landscape. The plants grow, develop leaves, and fill the rows across the field. Later comes the reproductive stage. Small flowers emerge, the first pods begin to appear, and inside them, the soybeans start to form, beans that may one day end up inside a carton of soy milk. While the field may look almost motionless, each pod is working like a tiny capsule. The beans grow larger and fill the space inside, until the appearance of the field itself begins to reveal that the growing cycle is nearing its end. The leaves lose their green color, turn yellow, and begin to fall. The pods dry out and shift to shades of brown or gray. The field that once looked like a green carpet takes on a dry, almost golden appearance. That is the signal that harvest is approaching. Then one of the most impressive machines in modern agriculture enters the scene, the combine harvester. Its massive front header moves close to the plants, cuts the soybeans, and feeds the crop into the machine. But cutting is only the first step. Inside, an impressive sequence takes place. The machine gathers the plants, threshes them to release the beans from the pods, and then separates the soybeans from straw and other plant material. Cleaning systems remove lighter debris while the beans move into the combine's grain tank. In a single pass, the crop is cut, collected, threshed, separated, and cleaned. The soybeans remain stored inside the machine, while much of the leftover plant material is returned to the field. And this operation demands precision. A poorly adjusted machine can crack beans, leave pods behind, or increase harvest losses. Cutting height, travel speed, and field conditions all affect the final result. When the grain tank fills up, an unloading auger transfers the soybeans into grain carts or trucks. On large farms, this transfer can happen while harvesting continues, allowing the combine to keep moving through the field. From there, the soybeans may be taken for receiving, drying, and storage before reaching their industrial destination. And not every harvested soybean becomes soy milk. Soybeans have many different uses, and only the batches intended for this production chain move on to beverage processing. When the soybeans finally arrive at the factory, they enter a far more tightly controlled environment. Dust, plant fragments, small stones, broken beans, and other impurities cannot be allowed farther down the line. Screening, aspiration, and separation systems remove this unwanted material. This level of care affects flavor, yield, color, and how the soybeans behave during grinding. Depending on the processing technology, the beans may also be partially or completely dehulled. Only then are they ready to meet the ingredient that triggers their first major transformation inside the factory: water. And if you watched our previous episode, you saw how powdered milk is made by removing much of the water from milk. With soy milk, the process moves in the opposite direction. Adding water is what begins to transform the soybeans and prepares them to release the components that will ultimately form the beverage. And that raises an interesting question. If you sent dry soybeans straight into the grinder, could you extract a smooth, uniform beverage from them? No. In industrial production, the beans first need to be prepared so their components can be released far more efficiently. Before we continue this transformation, check that you're subscribed to Factories and Facts and answer this in your head. Which step do you think changes the soybean the most? The water, the grinding, or the heat? In a moment, you'll discover that the answer may actually be a combination of all three. The clean soybeans move on to soaking. The beans remain in water for several hours, absorb part of it, swell, and become much softer. This preparation makes grinding easier and helps expose the components inside the beans. Next, the soybeans are ground with water. Instead of turning into a dry powder, they form a thick suspension, almost like a liquid paste. The equipment breaks the beans into smaller particles and disrupts their structure, allowing proteins, oil, and other components to move into the liquid phase. This is where many people assume the soy milk is already finished. It isn't. The mixture is still loaded with fiber and solid particles, and its texture is nothing like what eventually reaches your glass. There is also a flavor challenge. Soybeans contain enzymes that can contribute to their characteristic beany, plant-like aromas. That is why some processes use hot water, blanching, or heated grinding to quickly deactivate certain enzymes, including lipoxygenase. On some production lines, the mixture is also heated during or after grinding. The heat helps reduce naturally occurring anti-nutritional factors in soybeans. Everything has to be carefully controlled because too little or too much heating can compromise the final result. Now imagine thousands of gallons of this slurry moving through closed pipelines, with pumps, valves, and sensors controlling the flow. And if you're already looking at a simple soybean differently, hit the like button. It helps Factories and Facts keep revealing the hidden processes inside factories. But the most visual stage is still ahead. This slurry will be separated. On one side will be a wet, fibrous material. On the other, the liquid base of soy milk will finally appear. The mixture now reaches one of the factory's critical stages, separating the liquid phase from the insoluble material. Depending on the production line, filters, screens, presses, or centrifuges may be used. The liquid moves forward while fibers and larger particles are held back. The solid residue is called okara. It is moist and rich in fiber. And this material does not have to become waste. Depending on the operation, it can be repurposed in foods, high-fiber ingredients, or animal feed. While the okara moves on to another use, the liquid phase continues through the line. This is the moment when the transformation finally becomes recognizable. The soybean we saw being harvested from pods in the field now appears as a pale, milky beverage made from water and components extracted from the beans. But the product still is not finished. This liquid needs additional treatment to achieve consistent stability, safety, and flavor. And here's a myth worth clearing up. Soy milk is not made by squeezing a soybean until some hidden white liquid comes out. The beverage forms when the beans are soaked, broken down, and their components are extracted and dispersed in water. Its white appearance comes from that dispersion of proteins, tiny particles, and microscopic droplets of oil. The efficiency of this separation also affects yield. If too much liquid remains trapped in the okara, part of the product is lost with the residue. If too many large particles pass through, the beverage can feel gritty or develop sediment. After separation, the soy base can be adjusted according to the final formulation. Depending on the product, ingredients such as sugar, flavorings, vitamins, minerals, oil, salt, or stabilizers may be added. Fortified versions may also receive calcium and additional vitamins. That is why two soy beverages can taste and feel different even when they start with the same soybean. Extraction creates the base, while formulation helps shape the final product. And now another challenge appears. How do you keep water, proteins, oil, and microscopic particles evenly distributed without letting them separate into layers? The answer comes in the next stage, where pressure, heat, and precision equipment make the beverage far more stable. Now, the beverage enters the stage where engineering and precision make all the difference. After extraction and formulation adjustments, the soy base needs to become completely uniform. To achieve this, many production lines use homogenization, a process in which the liquid is forced through extremely narrow openings under high pressure. This reduces the size of droplets and clusters, helping distribute the components more evenly throughout the beverage. Homogenization helps prevent the beverage from separating into layers. Oil can rise, particles can settle, and proteins can clump together. By reducing and dispersing these structures, the factory aims for a smooth texture, a uniform appearance, and greater stability during storage. But physical stability is not enough. The beverage also needs the proper heat treatment. Refrigerated products may go through pasteurization followed by cold chain storage. Shelf-stable versions may use UHT processing, where the product is exposed to very high temperatures for just a few seconds before moving through aseptic conditions. The goal is to control microorganisms and extend shelf life without exposing the beverage to heat for too long. This stage requires extremely tight control. Sensors monitor temperature, pressure, flow rate, and holding time. If the product moves too quickly or fails to reach the required conditions, the treatment may be insufficient. If it receives too much heat, the flavor and other properties of the beverage can suffer. That is why the system is designed to repeat the same cycle continuously and predictably. There is another detail that surprises many people. On an aseptic production line, perfectly treating the beverage means nothing if it is later placed into a contaminated package. The product, pipelines, holding tank, and filling system all have to work as parts of the same sanitary barrier. Once treatment is complete, the beverage must be protected from any new contamination. That is why the final section of the factory often looks almost like a sealed circuit. The liquid travels through pipes, passes through heat exchangers, may move through the homogenizer, continues into dedicated tanks, and reaches the filling equipment without being freely exposed to the surrounding environment. Now I want to hear from you. Before watching this video, which steps seem the most unlikely? Turning the beans into a slurry, separating the okara, or stabilizing the beverage with pressure and heat? Tell us in the comments, and let us know your city and state too. It is always fascinating to see how far Factories and Facts is reaching across the country. Meanwhile, quality control continues. Samples may be tested at different points throughout the process to monitor characteristics such as composition, acidity, appearance, viscosity, and microbiological safety according to the specifications set for that product. The goal is to catch any deviation before thousands of units move on to shipping. In continuous production, just a few minutes can represent a huge volume of beverage. That is why quality control is not something performed only at the end. It follows the entire line, from the raw ingredients all the way to the packaged product. There is also an invisible battle against oxygen, excessive heat, and any condition that could affect flavor or stability. Closed equipment and strict cleaning procedures are essential for maintaining consistency. Between production runs, industrial systems can clean the inside of pipes and tanks without dismantling the entire line, removing residues that could compromise the next batch. By the time this stage is complete, the soybeans have traveled almost the entire journey. The liquid has been formulated, homogenized, and treated. Only one final transformation remains, less dramatic to watch, but critical to making sure everything reaches the consumer intact. Placing the beverage into a package designed to protect it until the moment you twist open the cap. In the final stage, the soy beverage reaches the filling line. If the product has been processed for shelf-stable storage, the packaging has to enter the system under conditions compatible with aseptic processing. The container is formed, filled, and sealed in a way that protects the beverage from the outside environment. From that point on, any sealing failure could put the stability of all the previous work at risk. The package is then moved through inspections and sealing checks, along with lot identification and date coding. Depending on the factory, cameras, sensors, and automated systems help verify the presence, position, coding, and integrity of each unit as it travels along the conveyor. Packages that fall outside specifications can be removed before they reach the grouping stage. Next, the individual units are packed into larger cases, arranged on pallets, and prepared for storage and distribution. It is remarkable to think that only a few hours earlier, this beverage was still a load of dry soybeans. Now it has been divided into thousands of nearly identical packages, each one carrying the result of sorting, soaking, grinding, separation, formulation, homogenization, heat treatment, and filling. At this point, logistics also becomes part of quality control. Producing the beverage correctly is only part of the job. The cases have to be organized, tracked, and shipped under the proper conditions for that specific product, protecting it until it reaches stores. And there is one more hidden detail in this story. The okara we saw removed during separation shows how modern factories try to make better use of raw materials. This byproduct still contains fiber and other components from the soybeans, and it can be used in food products or animal feed. So even the portion that does not end up in the beverage may still find a second purpose. Another important detail is that not every soy milk on store shelves is produced with exactly the same sequence, temperature profile, or formulation. Different technologies are used for refrigerated and shelf-stable products, as well as sweetened, unsweetened, flavored, and fortified varieties. But the core principle remains the same: extracting a stable, safe, and enjoyable liquid base from soybeans. And now it becomes easier to understand why describing this process as simply mixing soybeans with water leaves out almost everything that really happens. The factory has to control the beans before grinding, hydration before extraction, particle size before stabilization, heat before packaging, and sanitation throughout nearly the entire production line. Every stage solves a problem that would show up later in the product if it were ignored. The next time you open a carton of soy milk, you may see much more than a white beverage. Behind that glass are soybeans that absorbed water, machines that broke apart microscopic structures, filters that remove fiber, equipment operating under pressure, and thermal systems engineered to repeat the same conditions with remarkable precision. And to think it all began with a dry seed small enough to fit between two fingers. If you enjoyed discovering how soybeans become soy milk, subscribe to Factories and Facts for more industrial transformations that usually happen far from the consumer's eyes. And before you go, tell us in the comments which stage surprised you the most and what you learned today. The next everyday product in your home may be hiding an even more incredible factory. And if you think you've already seen it all, then you have no idea what we uncovered in our last episode. It's already appearing on your screen. Click it, and come with me to uncover another hidden secret here on Factories and Facts. Take care, I'll see you there.